And this is one of my senior design projects that I've really gotten a lot of joy out of over the years. This kind of goes back to a conversation I had once with a civil engineer who does large-scale recreational water facilities. And so he does hotel pools, he does water slides, splash pads, and he does lazy rivers. And so I got curious one day talking to him, like, how do you design lazy rivers? Because you're literally pumping water in a circle. This is completely different from every other engineering project that civil engineers do, where we're going from point A to point B. We're going from point A back to point A. And so I started talking to him. He's like, yeah, there's a bunch of rules of thumb. It's about this long or about this wide or about this fast. You need about this. And I go, is that all? I mean, that makes sense. I'm glad that they work, but I mean, we can do better. And so I started talking to him and like, so hypothetically, if we built a small scale lazy river and did some tests and experiments on it, would that be good? And so long story short, that's what we've been working on for the last couple of years, is building lazy rivers here on campus. Unfortunately, not the kind we can probably get in, but the kind that we can do tests on. And so we've learned a lot from this. We did some first initial lazy rivers out of concrete, but then we could only really test that one configuration. So this last year we had 7 seniors, 4 civil engineering students, 3 mechanical engineering students working on this project together. We built a modular lazy river. And so we built the sections of the lazy river, and we could fill it with water and pump it around and around and around. And we could learn how much power, how much velocity we want to put in. Where do we want nozzles? The big pumps, we want 1 big pump, 2 small pumps. We can do these experiments. And then we can break it down, because it's modular, into the smaller parts, and then reconfigure it into a different shape, where we can look at if it's straight or if it's curvy. How can we understand what's the relationship between these pumps and the river itself, and how fast the water is flowing through it? And so while it's incredibly fun, we're learning a lot from it. How you design better. Within civil, it's a really broad area. The kind of the 2 that we focus on here at LeTu, which are kind of the 2 most in-demand job professions, are structural and water resources. We also have an environmental engineering degree, which is growing quickly. So that's a big demand. That's where we kind of prepare our students for. But we prepare our students not specifically for a field. We educate them. We want them to be flexible. We want them to be knowledgeable problem solvers. So we give them this technical knowledge and structures in water resources, but we give them that understanding so they can problem solve and do all kinds of projects, whether it be bridges, skyscrapers, roads, pipes, water treatment systems, lazy rivers. So one of the cool things we do about engineering within civil, with the mechanical, is we do this hands-on kind of projects. And so it's very normal to have big spaces for big projects, and the projects are constantly changing. And so this space, while we have right now a lazy river in the back, I've seen a disaster relief shelter installed here. I've seen water treatment systems installed here. I've seen rebar bent here and concrete poured here. And we're constantly using our space for all kinds of different applications. So having this flexibility, because we want students working on a range of projects, is a really huge blessing for our program.